All right, 3.3, derivatives of inverse trig functions. And we start out with not trig functions, but just inverse functions in general. And I could read this to you, but it doesn't read real well. But the important piece is right here, actually. It says that derivatives of inverse functions at corresponding points are reciprocals of each other. And I have an example of this. Now, the example is not a proof. It just proves that it works for this one. But the theorem says it works for any inverse functions, that the derivative values at corresponding points are reciprocals of each other. So if we were to graph these two functions, make a little sketch, we have the point 4, 2. 1, 2, 3, 4, 2. And that's what square root of x looks like graphed. And it goes through the point 4, 2. Then x squared goes through 2, 4. 2, 4. And then their reflections over the line y equals x. And any of the reflections, any of the points that are reflections over the line y equals x, those are corresponding points on the inverse functions. So 4, 2 corresponds to 2, 4. That's the reflection over y equals x. So let's take the derivative. That's 1/2 x to the negative 1/2. And that's 1 over 2 square root of x. And we'll evaluate when x is equal to 4. So 1 over 2 square root of 4 is 2. So the slope is 1/4 here. Slope is 1/4. That's what we just found out. Our claim is the slope over here, and it kind of even looks like it already, the slope there we're claiming is 4. That's the claim. So let's find out. So y prime here is 2x. We'll evaluate when x is equal to 2, and I'll be darned, it's 4. So they are reciprocals of each other. So slopes at corresponding points of inverse functions are reciprocals of each other. Not opposite reciprocal. We're not claiming they're perpendicular, and they're not. I mean, it could be, I guess, but they're not in this case. And most of the time, they probably aren't. All right, we'll actually come back to this. Discuss inverse trig functions, their graphs, and principal values. All right, so let's do the inverse sine of square root of 3 over 2. That asks the question, what angle has a sine that's square root of 3 over 2? And that's pi over 3 has a sine of square root of 3 over 2. And that's its principal value. See, we evaluated this. So it would say evaluate this. If it said solve, you solve equations. So we would have sine of x is equal to square root of 3 over 2. We'd take the inverse sine of both sides. And now we could have all kinds of answers. We could have pi over 3. We could have 5 pi over 3. Let's see, 6. It would be 7 pi over 3. But these two are the same. Well, you could have all kinds of answers for that. All of them when you solve. When you evaluate, there's only one answer. That's it. There's just one. That's it. That's all you get. So we've seen this before. What's the square root of 16? 4. Square root of 16 is not negative 4. If I came up to you and said, hey, what's square root of 16? You said negative 4. I go, wrong. That's not what square root of 16 is. It's 4. Because we evaluate this. We solve this. X equals plus or minus 4. Now we give both answers when you solve. So there's a difference between evaluating and solving. So now the inverse sine of negative square root of 3 over 2. Anybody know what that is? There's only one answer. It is not. His answer was 5 pi over 6. Well, first of all, I think you meant 5 pi over 3, right? 5 pi over 3 is down here. And that would be a solution to this. 5 pi over 3 would be a solution to that. But the answer to this, when we evaluate, is negative pi over 3. Negative pi over 3. And that's the only answer you can answer. Now, 5 pi over 3 is the same place, but it's not one of the answers. You can't have that as an answer. So what can you have as an answer for inverse sine of x? Well, it must come from quadrant 1 for the positives and quadrant 4 for the negatives. But in order to get to values in the quadrant 4, you must go backwards. So the answer must be negative for negative values. It has to be. There's no other answer. Just like negative 4 is not an answer to the square root of 16. You can't say that. For solutions, you can have those. For inverse cosine, well, cosine's positive in quadrant 1 and 4. So this one's quadrant 1 and 2. That's where cosine's negative. And you can go forward. You have to go forward in that direction to get to those values. And then the last one is inverse tangent. Well, we got to find a place where tangent's positive and negative, and that's 1 and 4 as well, just like sine. So the inverse tangent of negative 1 is negative pi over 4. And that's the only answer it has when you evaluate. There's no other answer to that. Now, if you're solving an equation, now we have bunches of answers, all kinds. So there's a review of inverse trig and what we call the principal quadrants. Any questions? All right, let's keep going. Oh, I didn't clear this one. There we go. You know, I like to show you where stuff comes from, like the derivative of tangent is secant squared, and we can get that by writing tangent as sine over cosine and then doing the quotient rule. And there's a process to get these derivatives, but it's way confusing. So what I ask you to do is memorize these three right here. The derivative of inverse sine, cosine, or inverse sine. Oh, what is, inverse sine, inverse tangent, and inverse secant. Because the cofunctions, if you notice, are the same, except they just have negatives. So you have 3 things to memorize, not 6 things really. You just got to remember all the cofunctions, their derivatives are negative. And I'm not going to follow you home and make sure you memorize these. That's kind of on your own. Now I'm going to give you homework to do. We're going to have review assignments. But you might have to do a little extra work on your own to memorize these, to study a little bit. Maybe you won't. Maybe the homework and reviews will be enough. I don't know. You know, we're all individuals. All right, anyway, let's practice this. Find the derivative. So dy dx is equal to negative, because it's a cofunction, 1 over square root of 1 minus 1 over x squared. So it's really not 1 minus x squared, it's 1 minus what we're taking the inverse cosine of squared. But then we got to multiply by the derivative of the inside. So the chain rule follows you all the time. No matter what new derivative we do, we always have to worry about the chain rule. Well, that's the calculus. Now we have to worry about the algebra. Oh, and this might be, the microphone might be a little loud because I kind of tend to talk loud. Let me turn this down. I hope I didn't turn it down too much. Check, check, check. All right, that's good. If you have to listen to this at home, I'm probably blowing your eardrums out. Negative 1 over square root of, well, this is x squared over x squared. So that's x squared minus 1 over x squared. There's common denominator, and then times negative 1 over x squared. And you know, we're answer hunting for like multiple choice. What could the multiple choice possibly have as answers? That's what we're looking at here. Well, we can square root the top and the bottom individually. Like if you had the square root of 3/4, that's square root of 3 over 2. So the square root of x squared is the absolute value of x. So it's 1 over the absolute value of x, square root of x squared minus 1 times negative 1 over x squared. I guess I can get rid of the negatives. Negative times a negative. But then this x cancels out with one of these now in the denominator, right there. So we have final answer, 1 over x square root of x squared minus 1. Calculus is usually the easiest part of the problem in here. It's the algebra that'll get you. What's the matter? Anything? Good with that? Everybody good? Yeah? Okay. Y prime on this one. Now we've shown this, half of this, the inverse cosine is the new piece, but I had you practice this because I knew it was coming. So first times the derivative of the second times negative 2s. There's first times derivative of the second plus the second times the derivative of the first. And then the new piece is, let's see, inverse derivative of cosine negative 1 over square root of 1 minus s squared. So there's the entire derivative. That's the calculus. Now we have the algebra. Let's go answer hunting. So we cancel the 2's. That's negative s squared over square root of 1 minus s squared. And then there's not much we can do yet here. That looks a little cleaner. And 2 of them have the common denominator. 1 of them doesn't. So let's give this the common denominator. So on top we'll have negative s squared plus 1 minus s squared minus 1. All over square root of 1 minus s squared. So the 1's cancel out and we got it. Negative 2s squared over square root of 1 minus s squared. Everybody good there? Find the velocity, find the derivative, find the derivative. All right, so we're going to take some derivatives. We're just going to keep practicing. So velocity on this one is 1 over 1 plus this thing squared. So t to the 4th, and then times the derivative of the inside is 2t. And we'll evaluate when t is equal to 1. So that's 2 over 1 plus 1 to the 4th. That's 1. It's 2 over 2. And we might ask you to find the equation of the tangent line. Yeah? Oh, you can take the quiz now? Okay. You can stay through to the next period? Yes? Okay. All right, give me a second here. Oh, hold on, I got to download it. Can I download? Okay, I need a folder. Document. 1, 2. 90843. And you can use calculator. You'll need calculator on it, by the way. No, not you guys. Him. Here we go, get it. All right, here we go. Cotangent. Oh, we did tangent. Cotangent's almost exactly the same, except it's negative. So y prime is 1 over 1 plus this thing squared. Well, that would be t. And then times 1/2 t to the negative 1/2. So that's 1 over 2 square root of t times 1 plus t. Yes, it should be negative. Yes. There we go. Thank you. Find the derivative. All right, so something similar to one we already did, except I took the s out of this one. Made it a little easier, or they did. So y prime is equal to, we got 1/2 s squared minus 1 to the negative 1/2, and then times 2s. Yep. And then secant is 1 over the absolute value of s, square root of s squared minus 1. So there's the derivative of secant, inverse secant. The 2's cancel. We get s over square root of s squared minus 1. Then minus 1 over absolute value of s, square root of s squared minus 1. Well, we almost have the common denominator. This is missing the absolute value of s. So absolute value of s minus 1 over absolute value of s, square root of s squared minus 1. We can't cancel the absolute value of s's because of the minus 1. And why would we put it in and then cancel it out anyway? (36). That goes back to the very first thing we did, with the derivatives at corresponding points of inverse functions are reciprocals of each other. So on this one, I kind of like to do it A and B at the same time, essentially, instead of answering A and then answering B. Because it says, what is f of 1 and then what is f inverse of 3? Well, I'm guessing f of 1 is 3 and then f inverse of 3 is 1, because you switch x and y. So let's find out. F of 1 is 1 plus 2 plus 1 minus 1. Let's see, 2, 3, 4 minus 1. Yep, it's 3. So f inverse of 3 is 1. And that's how you did inverses in honors pre-calc and algebra 2. You switched x and y. Well, that's what we do here. But the added stuff now is f prime of 1. So the derivative at 1 is, let's see, 5x to the 4th plus 6x squared plus 1. If I plug 1 in there, 5 plus 6 plus 1, that's 12. So the derivative at 1 is 12. So f inverse prime of 3 must be 1/12. They're reciprocals of each other. We found the corresponding points. The derivatives at corresponding points are reciprocals of each other. Try this one. Go. If you're watching at home, fast forward. So this one, the derivative of inverse tangent is 1 over 1 plus that thing squared, and then times the derivative of the inside, which is 3, and that's letter D. What's the following is the slope of inverse tangent? All right, so dy dx is equal to 1 over 1 plus 4x squared. That's the derivative of inverse tangent, times 2. There's the chain rule. And we're evaluating when x is equal to 1. So 2 over, oh, wait. Yeah. Oh, yeah. 1 plus 4, 2/5. Yeah, I got it. 2/5, C. Now we change gears a little bit, back into reverse. Find a function that has a given derivative. Well, let's start with this. What's the derivative of x squared plus 3? Derivative is 2x. What's the derivative of x squared plus 6? 2x. What's the derivative of x squared minus pi? 2x. So there could be a constant, 2x. There could be a constant there, and that wouldn't affect the derivative. The derivative would be exactly the same no matter what constant you have. So now we're going backwards. We're saying the derivative is this. What is the function? And so 24, that's the derivative of inverse sine. So f of x is equal to inverse sine, except the little catch there is we just say it's plus some constant. They don't give us enough information to find out what that is, but it's plus, it could be plus something, and it could be plus 0. That's a constant. 26, what's y? Y is equal to, be careful. What would that be? Negative cosine, right? Negative cosine of x plus some constant. 28, that's the derivative of tangent. And 30, oh, they kind of trick you there. They try to disguise it. That's 1 over 1 plus x squared. They just have it as a negative power. So that's inverse tangent. There we go. We'll do a lot more of that in like the second half of the semester. We'll go backwards. It's called antiderivative, and then it's called integral also. Integral. All right, well, that's not DCA. That's Gateway Review. So this is, that's the section. There's really not much to it. There's some challenging algebra to it, but the only new stuff is these three things right here. Those three derivatives, and knowing that the cofunctions are negative. Otherwise, there's really not that much to this section. That's why we spend one day on it. We review it in the reviews, and then we test over it. How about a little gateway review? 5, the derivative, 1/2. 3x to the fourth minus 5 to the negative 1/2, but then times 12x to the third. So derivative of the inside. We have 6x to the third over square root of 3x to the fourth minus 5. That's what I would look for an answer on that one. First times the derivative of the second plus the second times the derivative of the first. So product rule, and now we just have to clean it up. We'll take an 8 out, and that's cosine squared of 8x minus sine squared of 8x. So 8 cosine of 16x. So that's a double angle formula for cosine. So that last line is the full credit answer. Anything short of that, I'm gonna give you 1. So that last line is worth 1 point. Cosecant, negative 4 cosecant 4x cotangent of 4x. There we go. So some of them aren't that lengthy. Some of them are pretty quick. Cotangent. So we have negative cosecant squared of pi over 4x to the fifth times 5 pi over 4x to the fourth. I suppose we could put that polynomial out front, but that's fine. That wouldn't matter. Multiple choice would probably have that out front. This one is 18x to the fifth. First times the derivative of the second plus the second times the derivative of the first, which is 1. And then there's really nothing to factor out. So the only thing I could do is maybe put that 4 out in front, but I'm not going to write a whole new line just for that. And then the last one. Bottom times the derivative of the top. So it starts out with bottom. Bottom times derivative of the top. I've had people on this start with the top, and then you miss a couple of them because there's a couple of quotient rules where you have to do. So you'll miss a couple of problems. Bottom times derivative of the top minus the top times the derivative of the bottom over the bottom squared, x to the 6th. If you start with the top, if you do top times derivative of the bottom, I just minus 2 right away. I don't even look at the rest. I don't care what the rest is if you start it backwards. So x squared, x secant squared of x, we can take an x squared out. I'm good. That would be, I need a 4. I probably should have put that out front. What am I doing? Let me try that again. Take an x squared out. That leaves 4x to the 4th. Secant squared of x to the 4th minus 3 tangent of x to the 4th. All over x to the 6th. And now we can cancel. Well, it just never ends. 4x to the 4th, secant squared of x to the 4th, minus 3 tangent of x to the 4th over x to the 4th.